Hi, we are a pool playing robot that tries to pocket pool balls into the holes of a pool table. Our team consists of Jyoti from Harvard and Piero and Max, both from MIT.
We chose this problem because we thought it comes with a lot of different interesting challenges. So if you think of yourself as a human playing pool, there's a lot of things that you need to take into account, like trying to avoid other balls on the table when you're setting up the cue, trying to avoid hitting the edge of the table. And then there's a lot of challenges here with a robotic simulation, including the perception algorithms, the actual like algorithm for the best shot, and of course the actual manipulation to execute the shot that we want to do.
Yeah, so our methodology overview basically consists of a three-state pipeline, starting with the pre-processing of perception, which I can get into in a bit right now. It entails of knowing the state of the board, basically where all the balls are located, both red and blue and the cue ball. We chose red and blue instead of solids versus stripes for simplicity because it's easier to detect whether it's red or blue versus solid and stripes. So the positions of the balls is essentially getting the center of the ball so that we know where to impact the cue ball to then impact the object ball. And this is also done for simplicity since we're only dealing with simple shots hitting the centers of the balls. So to do this, we place an RGBD camera at the top of the pool table at a top view from a bird's eye view. This converted the 3D scene to a 2D picture to get spheres into circles, which we can get the center of in XY coordinates. First, we had to segment the point cloud to get the points respective to each ball. Next, we had to do a k-means clustering algorithm to know which points belong to which individual ball. And lastly, we had to do a sum of least squares distance to know which point in respect to each ball would most likely be the center of that ball, since its distance would be the shortest to all the other points. Once these centers were acquired, we passed this along to the planning algorithm to know the best shot, which I'll hand over to Piero.
In order to determine the best shot, we use a scoring metric found from the literature review that essentially takes into account three metrics. One being the angle of the shot that you need to make. The second one being the distance from the cue ball to the target ball. So here being like the player ball that you're trying to strike. And then the third one being the distance from the player ball to the hole that you're trying to aim it into. So once we have all of these possible shots, we simply just score them and sort them by this metric. And then we just take the best one. And then using some trigonometry, we calculate the target that we need to aim for. And so this is the optimal shot vector that actually gets passed into the execution stage.
Yeah, and then once we're at the execution stage and we have the optimal shot to take, the first step is to create the trajectory and end effector space from the gripper position to the actual shot that needs to be taken. But one limitation there is that we're actually not able to use a mobile manipulation and mobile base. We're using a stationary base just due to time constraints. So we have to test out different locations around the pool table to see which one is actually viable and able to make that shot. In order to do this, we have a mathematical program that tries to convert the end effector trajectories into joint space trajectories to determine which position is best to actually, execute the trajectory. And then once that position is determined and the mathematical program is solved, we turn the original end effector trajectory from that position into like an actual, movement of the arm to shoot the ball using a differential inverse kinematics controller. Yeah, so here's a demo of what the arm looks like. As you see, there's a trajectory in the triads, and then once it shoots the ball, it hits the cue ball into the red ball, which eventually falls into the hole. Yeah, and here's a slightly less successful demo. As you can see here, the positions of the red balls aren't necessarily in the best position to, shoot it into the hole. So the cue ball tries to move the red ball and it's able to, but it's not able to actually pocket the red ball.
Finally, some limitations of the project, like I said, in terms of perceptions, definitely the red and blue balls versus solids and stripes. Solids and stripes are a little hard to detect and could probably leverage machine learning, such as convolutional neural networks, to recognize the pattern instead of the color, since the solids and stripes also different colors. So these small inaccuracies could probably be used to better predict the ball locations to reduce the errors and the impacts of where the balls are hit.
And in regards to the algorithm for calculating the best shot, a better process could be using a markup decision process to actually look ahead a couple of states into the future to determine what could be the most optimal action to take now.
Yes, and then for execution, the best set of like limitations here, as mentioned earlier, is just the fact that we're not able to utilize mobile manipulation and we have a stationary base. So utilizing that in the future is probably the best, set of future directions to take so that we have a cleaner shot and a better simulation of a pool simulation.
Thank you.
Thank you.
Thank you.